Okay, so this video is meant for my Concepts of Algebra 2 students. We do have a quiz coming up on Tuesday covering sections 6.4 through 6.6. So this is a review of some of those problems in those sections. First, find the product. So we're going to multiply. And notice, there's nothing really to multiply. It's just a binomial raised to the third power. But we need to know that the third power means write this thing 3 times. So I'll write it 3x plus 5 times 3x plus 5 times 3x plus 5. And what you need to do is work with 2 at a time. So let's work with the first 2. So 3x plus 5 times 3x plus 5, the first 2. So they're gone. And we will multiply by foiling. This first 3x goes to the other 3x and to the 5. 3x times 3x is 9x squared. 3x times positive 5 is positive 15x. And now we'll do the 5 to the 3x and to the positive 5. 5 times 3x is positive 15x. 5 times 5 is positive 25. Combine these middle terms, 9x squared plus 30x plus 25. And that's those first 2 multiply out to be. So we'll put that in a parenthesis because we cannot forget about the last parenthesis, the 3x plus 5. We have to now bring that down and now distribute these 3 terms into those 2 terms. Okay, so I use a different color, orange. So this 9x squared has to go to the 3x and has to go to the 5. So 9x squared times 3x, 9 times 3 is 27. X squared times x is x cubed. 9x squared times 5, 9 times 5 is 45. The x squared is an x squared still. And that's the 9x squared, done. Now we do the 30x. The 30x goes to the 3x and the 5. 30x times 3. 30 times 3 is 90. X times x is x squared. 30x times 5. 30 times 5 is 150. And the x just comes. And then the 30x is done. And now finally the 25 to the 3x and to the 5. 25 times 3x, 25 times 3 is 75. The x comes along. 25 times 5 is 125. And now we just combine any like terms we see. Highest power first. 27x cubed is the only x cubed. 45x squared and 90x squared, both positive, so just add them together. 135x squared. The x's come next, 150 and 75. They're both positive, so just add them. 150 and 75 is 225x. And then lastly, the 125 is the only number. And it's done. And there is your simplified product for this binomial cubed. Okay, here's our second problem. We're going to long divide. And remember, when we long divide, first thing is make sure our polynomials are in standard form. And they have to have all powers of x. So notice this first polynomial, 6x cubed minus x squared plus 7. Missing the x term. So you actually have to rewrite this as 6x cubed minus x squared plus 0x. You have to have that in there. Now the other one is fine because it starts with x and then goes to a number, so that's fine. So this is the true division problem we're going to do. Okay? So the second polynomial goes on the outside. The first one goes on the inside. And now, it's always comparing the first term with the first term, x, with 6x cubed. To make x become 6x cubed, I need to multiply by 6x squared. It's going to go over the x squared term. 2 terms here, it goes over the second term here. And what do I do with that 6x squared? I distribute it. And I get 6x cubed plus 6x squared. And then I subtract, but subtraction really means flipping the signs. Distributing a negative, which flips the signs. And the 6x cubes cancel. And negative 1x squared minus 6x is negative 7x squared. And we bring down the next term, plus 0x. And now again, we go back. Compare your first terms. X with the new first term, negative 7x squared. To make x negative 7x squared, multiply by negative 7x. And distribute. Negative 7 times x is negative 7x squared. Negative 7 times 1 is negative 7x. Now we subtract. And subtraction means change these signs. The 7x squareds cancel. 0 plus 7 is 7x. Bring down the plus 7. And again, last step, compare this first term with this first term to make x become 7x, multiply by a positive 7. Distribute the 7 to the x and the 1. 7x plus 7. Subtract means change the signs. The 7x canceled and the 7's canceled, so your remainder is actually 0. So the main part of the answer is this top thing, 6x squared minus 7x plus 7. If you have a remainder, remember you add the remainder over what you divided by, but because your remainder is 0, that doesn't matter. And here's your answer, 6x squared minus 7x plus 7. Division. Okay, here's our next problem. We have to factor the polynomial, and I know this has some difference of 2 cubes. You're not going to see that on the quiz, so make sure you can recognize, okay? Well, I have this 125x cubed minus 64. The first thing I look for is a common factor. And I say, okay, 125 and 64. 125, what? I have 1, 5, 25. Those don't go into 64, so there's no common factor between the big numbers. Now, the 64 does not have an x, so there's no x common either. So there is nothing common. So then the question is, how does this factor? Well, let's look at 125. 125 is 5 cubed. The x is already cubed, which should give you a hint that this is going to be a perfect cube. And 64 is 4 cubed. Here is your perfect cubes. Everything's a perfect cube. We can factor it using the difference of perfect cubes. A cubed minus b cubed, which is a minus b, a squared plus ab plus b squared. And remember, the signs are same, opposite, always positive. So in this case, a is 2 things, 5 and x. So when I see the a, I put a 5 and an x. Minus, b is 1 thing, it's a 4. So put a 4. 5x minus 4. A again is 2 things, 5 and x. So when I square a, I have to square both. 5 squared, x squared. Plus, a is 2 things, 5 and x, times b. b is 4. Plus, b squared. b is 4 squared. So this is 5x minus 4. And then we just simplify. This is 25x squared, plus this becomes 20x in the center, and 4 squared is 16. And there's your perfect cubes factored. Okay, now we're going to solve this equation. And when you solve, first thing is get everything on one side. You can't work on 2 sides. So let's bring this 4x over with everything else. So it's positive 4x, so let's subtract it. Notice there are no other x terms, so the 4x will not combine with anything. Write it in standard form. X cubed minus 2x squared minus 4x plus 8 equals 0. So now that it's set equal to 0, now we can look to factor. Now, 4 terms factored by grouping. First, though, let's look for a common factor in all 4 terms. This is a 1, so there is no coefficient there, so no big numbers. And the 8 does not have an x, so no. There's no common factors. So now we do the factor by grouping, which is linking them 2 at a time. X cubed minus x squared both have an x squared. That leaves me with x minus 2 left over. We bring down the middle minus sign, and now 4x and 8, there's a common factor of a 4. Now you have to think of this 4 as a negative 4, so when you pull the negative 4 out, you get x, and when you pull a negative 4 from a positive 8, you get negative 2. And there's that repeating factor that should happen, x minus 2. So we pull that out in front, x minus 2, it's gone both times, and the second parenthesis has what's left over, x squared minus 4. And this is factored. And let's set each one equal to 0. So here, add 2. So x equals 2, there's one of my solutions. On this one, you have an x squared, add 4. And now let's take the square root. When you take the square root of x squared, you get x. When you take the square root of a number, you get 2 answers. And the square root of 4 is actually 2. So there's your other 2 solutions. So 2, 2, and negative 2. Alright? So again, if you want to write them out separately, 2 and negative 2 from this. So you have a repeated solution, right? 2 is repeated, and that's just extra information. But there's your 3 solutions, 2, 2, and negative 2. Factor by grouping. Okay, here's the biggie problem. Okay, if you don't know how to do this, you're in trouble. Here we go. A package has a height of x inches, a width of 3x minus 2 inches, and a length of 3x minus 7 inches. The volume is 42 cubic inches. So let's draw a picture. Box has a height of x inches, a width of 3x minus 2 inches, and a length of 3x minus 7 inches. And the actual volume is 42 inches cubed. So part A says, use the formula for the volume of a prism to write an equation of the volume of the package. Okay, So we know that the volume equals length times width times height. So let's fill in what we know. Okay, I'm going to slide down. We'll come back to the top in a sec. So the actual volume is 42. The length is 3x minus 7. Let's put a parenthesis around that. Times the width. The width is 3x minus 2. Let's put a parenthesis around that. And then the height is x. And you can put a parenthesis or not. It doesn't matter. I need to work on one side of this equation. Well, before I do that, let's simplify the right side. Let's get these parentheses gone. Let's multiply these three things. Remember, 2 at a time. Let's do the two parentheses. 3x minus 7, 3x minus 2. Multiply those two things. 3x goes to the 3x and the 2. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. The negative 7 goes to both things. Negative 7 times 3x is negative 21x. Negative 7 times negative 2 is positive 14. And the middle term will combine to give me negative 27x. And there's the first two parentheses multiplied together. Now do not forget about this x. That's why I put this in parentheses, because this x has to go in there as well. And I'll also bring down the 42 equals. So this x is going to be distributed into the parenthesis. So on this side we'll stay 42. But now all of the x's add an exponent. 9x cubed minus 27x squared. And the 14 now gets an x. And this is what they want. That's part A. That's the equation for the volume. So now part B says, let's go back to the top. Part B says, solve the equation for part A. Use your solution to calculate the dimensions of the package. Okay. So part B says, let's solve. Well, to solve, move your 42 to this side. Does not combine with anything. So we will get 0 equals 9x cubed minus 27x squared plus 14x minus 42. And there's 4 terms now. We're factored by grouping. First, though, I'm going to look for the common factor in all 4 terms. 1, 2, 3, 4 terms. 9 has factors of 3 and 9. We'll go into 27, but we'll not go into 14 or 42. So no big numbers. The 42 has no x, so there is no common factor. So now we group them in 2s. Alright. The first 2 terms share a 9 and an x squared. Leaves you with x minus 3. Bring down the plus sign. The second 2 terms, this is kind of tricky because 14 and 42 are big, but 14 actually goes into both. And when you divide 42 by 14, you get 3. There's my repeating factor of x minus 3. So I'll pull that way out in front. It goes away both times. 9x squared plus 14 is left in its place. And that's factored. That's factored. So follow my blue up here. I'm going to save some space. Now we set each one equal to 0. 9 minus, or x minus 3 equals 0. 9x squared plus 14 equals 0. For the x minus 3, simple, add 3. And there's the value of x. For this one, subtract the 14 because we want to get the x squared alone. Divide by 9. And then to get x all alone, we take a square root. But when you take the square root of a negative number, those are imaginary numbers, and we don't care. So the only value of x is 3. And there's your x value for this problem. X equals 3. So they want the dimensions. So if x is 3, we go back to the top, plug in 3. 3 times 3 minus 7, that's 9 minus 7 is 2 inches, by 3 times 3 is 9, 9 minus 2 is 7 inches, by, and then the height is just x, so that's 3 inches. And 2 times 7 is 14, times 3 is 42, and that works out. So make sure you know how to do this problem. It's very important. A lot of steps, I know. Take your time, you'll do fine. Alright, we got 2 more problems left. Here we're going to factor again. Okay, so we're not solving, we're just factoring. So I look at these 2 terms, and I say, oh, 5th power. Well, let's see what we can do. Common factor. 3 and 48. 3 does go into 48, so 3 is common, and they both have x. So I can pull an x to the first power out. So our common factor is 3x. That leaves me with x to the 4th minus, and 3 goes into 48 16 times. The x came out. And now I say, can this go any further? Well, x to the 4th, well, 16 is a perfect square, right? 16 is 4 squared. So maybe x to the 4th is a perfect square. Does something squared give you x to the 4th? Well, yeah. x squared squared. So there's a difference of perfect squares. Now, I want to put a star up here so I don't forget that 3x. It has to go in the final answer. So this difference of perfect squares factors into two parentheses, x squared and 4, x squared and 4, different signs, plus and minus. And now, are we finished? Well, x squared plus 4, that's a sum, so we're done. But what about x squared minus 4? This is another difference, and 4 is a perfect square. 4 is 2 squared. This is another difference of perfect squares. Two parentheses, x and 2, 1 plus, 1 minus. And this is done. Bring down the x squared plus 4. That's done. Bring down the 3x. And now you're fully factored. Okay. So that would be it. That's a difference of perfect squares, starting with an x to the 4th. Good problem. Alright, here's the last problem of the day. Another solving problem, so we're going to solve the polynomial. And first, it's an equation, can only work on one side. So let's bring this 2x to the 4th to the left by subtracting it. It's x to the 6th, the highest power, so we'll bring it to that side. So we get 2x to the 6th minus 2x to the 4th minus 60x squared equals 0. And now that it's set equal to 0, we can look to factor. First is a common factor. 2, 60. Take out a 2. X to the 6th, x to the 4th, x squared. Take out an x squared. So this is going to reduce us pretty considerably. So we got a 2x squared out in front. What does that become? Well, the 2 comes out. The x to the 6th becomes x to the 4th. For this minus 2, 2 comes out, leaves you a 1. You don't need to put the 1 there if you want to. X to the 4th, take away 2 x's, becomes x squared. Minus comes down. The 60, when you divide it by 2, is 30. And the x squared, when you take it out, the x squared goes away. And there's my factored form. So now here, set each one equal to 0. 2x squared equals 0. X to the 4th minus x squared minus 30 equals 0. Here, get the x squared alone. Divide by 2. X squared equals 0. Take the square root. Now you get two answers, plus or minus, but remember, 0 is neither positive nor negative. So you get two answers of 0. And there's 2 of the 6 solutions to this problem. Okay, now what about this thing? This thing is not factored yet. I have 2 x's with different exponents. This is like that ax squared plus bx plus c. Okay, except instead of x squared and x, it's x to the 4th and x squared. No big deal. There is no a, so you're lucky. C is negative 30. So the factors of 30 are 1 and 30. C is negative, that means different signs. And then the b is negative, that means the bigger number is negative. So 30 is negative, 1 is positive, that's negative 29. I want a negative 1, right? There's a negative 1 in the center, so I got to keep going. 2 and 15, big negative, small positive, negative 13. No. 3 and 10, big negative, small positive. No. 4 does not. 5 and 6, big negative, small positive. There we go, magic numbers. Plus 5, minus 6. So what I will do is I will put 2 parentheses with x squareds this time, because it's x to the 4th, and one parenthesis gets the plus 5, the other one gets the minus 6. And this is again factored, so set each one equal to 0 and solve. So x squared plus 5 equals 0, x squared minus 6 equals 0. Here, get the x squared alone by subtracting 5 and take the square root. Now when you subtract 5, you get a negative 5, so you're taking the square root of a negative number. That's imaginary. You don't have to worry about them. So 2 of the answers are imaginary. Here, add 6, x squared equals 6. Take the square root, take the square root. X equals plus or minus. Does 6 break down? Well, 6 is 2 and 3, but those aren't perfect squares, so no, it doesn't. So you get positive or negative 6. So your 6 answers are 2 of them are 0, one's positive square root of 6, one's negative square root of 6, and then the other 2 are imaginary. Okay? Alright, so thanks for watching. Hope you feel prepared for your quiz on Tuesday, and we'll see you then.